Group 6, the Intelligent Laser Scarecrow. I'm Michael Holden, and this is Harry Wu. Hundreds of millions of dollars in crop damage occur each year in the U.S. alone from various bird species, even with millions spent on deterrent systems like Scarecrow or auditory scare devices. Early products and prototypes, however, have revealed that light and laser-based deterrent systems can be up to 80% more effective than traditional means, as repeated exposure to these systems causes increased wariness rather than gradual adaptation. Unfortunately, these early systems are incredibly expensive and often simplistic, relying on timers or simple motion activation, which doesn't really capture bird presence. Thus, these systems often waste energy and fail at consistent deterrence, which could also interfere with human activities. Our team integrates a portable laser system with visual recognition software to produce a consistent, harmless means of deterrence at a quarter of the price for some existing systems.
This is the PCB for the Laser Scarecrow system. As of right now, this is predominantly used to reduce the footprint of the system as well as improving the overall stability. Here we have the input from an external power source, wall power 120 volts AC, and it will go into our commercial off-the-shelf AC-DC converter, which will step it down to 5 volts. From there, it will connect to these two sets of pins, which are connected externally to a Raspberry Pi 5 and a ESP32 Dev Kit C, respectively. We have included here some bypass capacitors to help improve the stability of the power supply. And finally, we have external pins and screw terminals here as to connect to the servos and the laser.
We've designed a simple 3D shell that integrates with a security camera dome for debris and weather protection. The entire 3D shell attaches to our pole system and contains all electronics and wiring responsible for making the system run. The system is designed to interlock with a highly mobile, stable pole platform as mentioned. The pole is high enough to allow the system to peer over tall crops like corn and grapevines, while being thin enough to minimally interfere with harvesting vehicles and personnel. Additionally, the system is secured into the ground with an auger tip that can be installed by hand or drill. This avoids digging up sections of the field or introducing foreign materials like concrete, and allows for install and takedown in just minutes.
We are running a Python-based camera vision system on a Raspberry Pi 5 using the Ultralytics YOLO V12 models. By capturing still images from the attached Pi camera on the Pi 5, the Pi 5 then compares what object on the screen to the training database model, assigning object classification and confidence levels. By tuning this model to detect birds, we then offload the motion program to a peripheral ESP32, which converts the location of the bird into instructions that it then transmits to control the servo and the laser.
Initially, we started with just visual recognition of objects, a demo of which you can see here on the screen. From there, we moved on to turning a servo left or right based on phone detection. The next step was mounting the camera onto the servo and then creating a small self-contained platform out of cardboard to follow a phone for our first demonstration. We then upgraded to proper mounted power components and some 3D printed parts for our second demo. Currently, we're working on tweaking the responsiveness of the program and making the chassis more secure and aesthetic.
For future improvements, we intend to move away from the low power red laser, which we are going to use for this demonstration for the safety of the audience and spectators, towards a high power green laser, along with the necessary driving circuits directly integrated onto the PCB. We will also move away from using the dev kit and the single board computer of the ESP32 and the Raspberry Pi 5 respectively, and integrating the microcontroller and microprocessor directly on onto the PCB as well to reduce the footprint. We also intend to add a battery to the Laser Scarecrow to remove the reliance on connection to the wall power as to enable greater freedom of movement of the device throughout the field. We may potentially also look at utilizing solar power to charge this.
Thank you for watching and learning a bit about our capstone journey.
We hope to see you at the expo soon.